Hi everyone, in this video let's see 20 MCQs in synchronous machine. The first question is the slip rings employed in a three-phase synchronous machines are insulated for. Options are output rated voltage, low voltage, very low voltage or very high voltage. Here the correct option is B, low voltage. Because in a three-phase synchronous generator, slip rings are used to supply DC excitation current to the rotor winding, which creates the necessary magnetic field for synchronous operation. These slip rings are insulated for low voltage. Next question. The number of poles on turbo alternator is usually. Options are 2, 4, 6 or 8. In a turbo alternator, achieving high speed requires minimizing the number of poles because the synchronous speed ns is 120 f by p. This expression is clearly say that ns is inversely proportional to the number of poles. For high speed applications, we typically use a minimum 2 poles since having only one pole is not feasible in practice. Therefore, to achieve the required high speed of the alternator is designed with 2 poles. Let's see the next question. In a salient pole synchronous machine, the air gap is options are uniform under the whole pole shoe. Option B is least under the middle of the pole shoe and increases outwards. Option C is largest under the middle of the pole shoe and decreases outwards. And option D is the least at one end of the pole shoe and increases to maximum value at the other end. Here for this question, the air gap in a salient pole synchronous uh, machine is non-uniform with the minimum air gap under the pole shoe and the maximum air gap in between of the poles. So here option B is the correct answer. It is least under the middle of the pole shoe and increases outwards. Next question. Which one of the following is the primary reason for placing field and rotor in an alternator? Options are small power in the field circuit, or insulation of high voltage is made easy on stator than on rotor, or large power in stator, or large current in the stator. Here in general, synchronous machine, armature on stator and field is on rotor. The primary reason for placing the field winding on the rotor is that the stator typically carries the high voltage and high currents output of the alternator. By placing the armature winding on the stator, it becomes easier to insulate the high voltage from the machine. Here answer in these options, D and B is the correct answer, but for primary reason it carries very large current in the stator, so option D is the correct here. Next question. In a synchronous machine, if the field flux axis is head of the armature field axis in the direction of rotation, the machine operating is. Options are synchronous generator, synchronous motor, or asynchronous generator. Here, in a synchronous machine, if the field axis leads the armature field axis in the direction of rotation, it indicates that the machine is operating as a generator and is supplying active power to the grid. So here option A is the correct answer, synchronous generator. Okay, next question. Which type of alternator is used in hydroelectric power station? Options are non-salient pole alternator, turbo generator, salient pole alternator, or steam turbine alternator. Here the option is correct answer is C, salient pole alternators, because hydroelectric power plant operate at low speed. In low speed applications, salient pole alternators are preferred. Next question. Consider the following statements. The synchronous generators used in thermal power stations have options are cylindrical rotors, slip rings and brushes, laminated rotor, or stator slots in multiples of 6 and three-phase star connected windings. Which of the following statements are correct here? If we see it in first option, cylindrical rotor in thermal power plant, alternators used in thermal power plants are rotated at very high speed. This feature we can see it in cylindrical type rotor. So in thermal power plant, cylindrical rotor types are rotors are preferred. Next one, slip rings and brushes. Here slip rings and brushes are used in alternators to handle low DC field current. So this second one also is the correct answer. Next, laminated rotors. These laminated rotors are used in hydroelectric power plant, which is usually rotated at very low speed. In high speed machines, is made up of solid steel forging with slots to hold the field winding. So option 4 is the correct answer. Option 3 is not correct. And uh, option 4 status lots in the multiples of 6. In general, the multiples of 6 design help achieve balanced efficient three phase operation in most of AC machines. uh, in synchronous machine, they it use status lots in the multiple of 6 are used as both generators and motors. Next, fifth one, three-phase star-connected winding. Due to circulating currents produced in the delta winding, synchronous machines are connected in three-phase star winding rather than the delta connection. Here, option D is the correct one. Next question. In a synchronous machine, damper windings are used to. Options are help in starting as a motor, run it as an induction motor, helps in starting as a motor, and to reduce hunting, increase efficiency. In a synchronous machine, damper windings are used to start the machine and reduce the hunting. Here option C is the correct one. Help in starting as a motor and to reduce hunting. Next question. Consider the following statements. Modern alternators are designed for large air gap to have options are large inherent regulation, very stable parallel operation, higher stability limit, or sinusoidal MMF distribution. Here, large air gap enables the machine to have very stable parallel operation and maintains higher stability limit and gives sinusoidal MMF distribution. Here option B is the correct one. 2, 3 and 4. Next question. The aircraft alternators are designed to generate EMF of high frequency of 400 Hz in order to. Options are compensate for high speeds, reduce the bulk, and option C is the make the system free from external disturbances, or all of the above. Here, aircraft alternators are designed to generate a high frequency of 400 Hz to make plane lighter, which increases the cargo capacity and decreases the fuel consumption. So here option B is the correct one, reduce the bulk. Next question. Squirrel cage bars placed in the rotor pole faces of an alternator help reducing hunting. Options are above synchronous speed, below synchronous speed only, or above and below synchronous speed, so both are none of the above. Here it will give this squirrel cage bars will give and rotate above and below the synchronous speed. Option C is the correct one here. Next question. Consider the following materials for line conductors. Options are hard-run copper, cadmium copper, aluminium, galvanized steel. The correct sequence of descending order of their electrical conductivity is compared to all the options, hard-run copper is giving highest conductivity, then cadmium copper, then after that aluminium, next galvanized steel will come. Here descending order represents highest conductivity to lowest conductivity. So the option D is the correct one here. Next question is, if the dimensions of all the parts of synchronous generator and the number of field and the armature turns are doubled, then the generator voltage will change by a factor of. Options are 1, 2, 4, 8. The generator voltage in a synchronous generator is given by E is directly proportional to T pi F, where T is the number of turns and pi is the uh, flux flux in Webers and F is the frequency. In this case, doubling the number of turns means it doubles the voltage, so 2n, and doubling all dimensions means it includes the radius and length, so it increases the cross sectional area by a factor of 4. Since magnetic flux pi is proportional to cross-sectional area, this increased by a factor of 4. Since E is directly proportional to T into pi, T is 2T and pi is 4 pi. 2 4s are 8, so E is equal to 8 n pi. Therefore, generator voltage will increase by a factor of 8 here. So option D is the correct one. In 37 question figure is missed, so we will see to another question. Match list 1 with list 2 and select the correct answer using the codes given below. Here turbo alternator parts are given in list 1 and in list 2 materials are given which are used to made list 1 parts. Let's match the correct codes here. For stator core is made up of silicon steel. For A3 is the correct code. And turbo alternators in thermal power plants are high speed alternators. So here rotor is made up of milled steel. For B, 4 is the correct one. Everyone knows that stator windings are made up of copper. For slip rings, it is made up of copper alloy. For this question, D is the correct answer. Next question. The most appropriate operating speeds in RPM of generators used in thermal, nuclear and hydropower plants would respectively be. Mm, Options are 3000 RPM, 300 RPM and 500 RPM. Option B is 3000, 3000 and 300 RPM. And C is the 1500 or 1500 and 3000 RPM. D is the 1900 and 750 RPM. The generators used in thermal and nuclear power plants are very high speed alternators, and in hydropower plant the generator used is here is very low speed. So option B is the correct one. 3000 rpm, 3000 rpm and 300 rpm. Next question. The maximum possible speed at which an alternator can be driven to generate a 50 Hz and 4000 volts is. The options are 4000 rpm, option B is 3600 rpm, and C is 3000 rpm, and D is 1500 rpm. Here, to determine the maximum speed at which an alternator can be driven to generate a specific frequency, we need to use the formula F is equal to Pn by 120, where P is the number of poles in an alternator, F is the frequency in Hz. Rearranging this formula, n is the speed of the speed. To find n, 120 F by P. It is a alternator in revolution per minute. For a frequency of 50 Hz, the maximum speed occur when the alternator has a minimum number of poles, which is 2. For a single phase 2 pole machine, this is a single phase and 2 pole machine. This n is equal to 120 into 50 into by 2, we will get a 3000 rpm. So the maximum possible speed for an alternator to generate 50 Hz is 3000 rpm. So here voltage does not affect the speed. So here voltage is independent of frequency and next speed. Next question. Three-phase alternators are invariably connected in star so as to reduce the magnetic losses or reduce the size of the stator conductors used. Option C is the increase the terminal voltage, or all of the above. Here the correct option is C. It increases the terminal voltage. Next question. Two mechanically coupled alternators deliver power at 50 Hz and 60 Hz respectively. The highest speed of alternator is. Options are 3600 rpm, 3000 rpm, 600 rpm or 500 rpm. Here two machines are coupled together, so we expect that speed is same here. N1 is equal to N2, so N1 is equal to 120 F1 by P1, N2 is equal to 120 F2 by P2. So we equal these two speeds. N1 is equal to N2, 120 F1 by P1 is equal to 120 F2 by P2. 120 120 get cancelled out. We will get F1 by P1 is equal to F2 by P2. Substitute these frequency values here. 50 by P1 is equal to 60 by P2. So 0 0 get cancelled out. We will get P2 is equal to 6 by 5 times of P1. 5 ones are 5, 1.2 times of P1. So P2 is equal to 1.2 P1. To eliminate the point here, we have to multiply 1.2 with 10. So assume P1 is equal to 10 because it should be even number. P2 must be even natural number. So P2 is equal to 12, P1 is equal to 10. So we have to find out the speed here. N1 is equal to 120 into 50 by 10 poles. So 0 0 get cancelled out. So multiply 120 with 5, we will get 600 rpm. So the answer here is the C, correct answer. Next question. The stator core stampings also have openings which make dash ventilating ducts to provide efficient cooling. Here it will provide axial and as well as radial ventilating ducts are used in stator. So option C is the correct one here.